in the question number 16, a block of mass m is kept over another block of mass 2m and system rests on a smooth horizontal surface. The coefficient of friction between the blocks is 0.50. Find the work done by the force of friction on the smaller block by the bigger block during a displacement d of the system when a force mg is applied to the lower block. Okay, so if I go for the diagram, so this is the block of mass 2m and another is m. According to the problem, force F is there and value of this force is mg. So first I am going to calculate the acceleration of the system. So for the acceleration, first I will write the net force, that is mg, divide by the total mass 2m plus m, that is 3m, so we'll get g by 3. Why we are going to calculate this acceleration? मैं ये कहना चाह रहा हूं कि इस एक्सेलरेशन से अगर ये सिस्टम मूव करता है तो दिस स्मॉल m will experience a pseudo force on the back side. So this block m has a tendency to slide on left hand side. So there is a relative motion between small m and 2m. If there is a relative motion, then friction will act on the right hand side, because friction will oppose the relative motion. And if I go for the value of this friction force, so it will be mu mg. If I place the value of coefficient of friction, that is 0.50 into mg, friction force is 0.50 mg, so we'll write mg by 2. So this is the value of friction force mg by 2. But if I go for this pseudo force, so this is mg by 3, because acceleration is g by 3. हम लोग यहाँ पे देख रहे friction force is greater than this pseudo force. System will move together. One thing, सिस्टम साथ में मूव करेगा, बिकॉज ये जो mg by 3 है pseudo force, आप थोड़ी देर के लिए इसको जस्ट वो फोर्स मान सकते हैं जो m को 2m से डिस्प्लेस कर सकता है, बट वो वैल्यू फ्रिक्शन फोर्स से कम है. वन थिंग इज इंपॉर्टेंट, आई वुड लाइक टू से दिस इज द वैल्यू ऑफ मैक्सिमम फ्रिक्शन फोर्स. बट if I ask you ki what will be the value of friction force in this question, so you will take only mg by 3, because friction force is a self-adjustable force. So now I am going to calculate the work done by friction force. So that is given by force into displacement, but you have to very careful. यहाँ पर जो मैं वैल्यू पुट करूंगा वो mg by 3 instead of mg by 2, because friction force is a self-adjustable force. और जो वैल्यू आपने गेन की है वो है मैक्सिमम फ्रिक्शनल फोर्स. सो वी विल राइट हियर mg by 3 and the displacement as per the question is d. So this is d, and the direction of friction force along with the direction of motion. So value of cos theta will be cos 0, that is equal to 1. So my final answer is mgd divided by 3. So we can say my option number 1 is correct. Let's move on question number 17. So now I am going to take the question number 17. In this question, particle moves from a point 2, 3, 0, 3, 2, 0 under the action of force 5 Newton. Acting along the line y is equal to x, the work done by the force on the particle during this displacement. So first I am going to take the situation of the force. So we'll write like this. But why? Because according to the problem, force acting along this equation. So if I compare this equation by mx plus c, this is equation 1 and this is my equation number 2. So if I compare equation 1 and 2, we'll get slope m1 is 1, and you know slope is calculated by tan theta. Tan theta is equal to 1 and this is equal to 1. So we can write theta is 45 degree. And this is the force. So we can take this angle is 45 degree. This is y and this is x. So if I go for the vector of force, so we'll write F cos 45 along x-axis, F cos 45, and similarly F sin 45 along y-axis. Cos 45 is equal to 1 upon root 2 and sin 45 is equal to 1 upon root 2. So we'll write F upon root 2 I cap j cap only. So this is the force. And second, for the calculation of work, I need the displacement delta r. And displacement is calculated by x2 minus x1 I cap plus y2 minus y1 j cap. I am not interested regarding z axis because the coordinate of z axis are 0 and 0. So you know that the coordinates are 2, 3 and 3, 2. So this is x1 y1 and this is x2 y2. As I said, I am not interested regarding z axis because value is 0. So when I place the value of x2 3, x1 2, so we'll get 3 minus 2 I cap, and the value of y2 is 2, y1 is 3, j cap. So the displacement vector is I cap minus j cap. This is the displacement. As per the definition of work, we all know work is calculated by the dot product between force and displacement. When I will take the dot product between this force and this displacement, will get 0. So my work done by the force on the particle during the displacement is 0. So my option number 4 is correct. Let's move on. Question number 18. In the question number 18, when a constant power is delivered to an object, then the graph between velocity and position of object is and motion of object is along x-axis. So we know that the power is given by F v cos theta, or you can say dot product between force and velocity. But according to the problem, motion of object is along x-axis. So we can take theta is equal to 0. So we can write the power is given by force into velocity, and force is given by mass into acceleration into v. And we can replace acceleration in terms of v dv over dx, because we know when velocity is the function of position, then acceleration you can write v dv over dx. So we will write mv square dv dx, that is equal to the power. Because power is constant, so if I write like this, p upon m, so that is equal v square dv over dx. So we can take this p upon m as a constant, so we'll write v square dv is proportional to dx. because क्वेश्चन में पावर को कांस्टेंट दिया गया है, मास को हम लोग कांस्टेंट लिख सकते हैं. सो व्हेन यू रिमूव दिस टर्म p अपॉन m, विल राइट v स्क्वायर dv डायरेक्टली प्रोपोर्शनल टू dx. सो नाउ आई एम गोइंग टू टेक इंटीग्रेशन. सो विल गेट v क्यूब अपॉन 3 is directly proportional to x, and 3 is a numeric constant. So we have v is directly proportional to x to the power 1 by 3. So with the help of this relation between velocity and position, we can say that the graph number 4 is correct. So let's move on question number 19. So I am going to take the question number 19. Potential energy of particle along x-axis varies with this equation. U is in joule, x is in meter, hence the particle is in. I need to calculate the type of equilibrium. So first I am going to take du over dx. So when I will differentiate this equation, will get minus 0 plus 2x minus 2, 2 minus 1 into 1 minus 0, because 2 is a constant. So this is the differentiation of given expression 2x minus 2. And we know that in the case of if u is minimum or maximum, if u is minimum or maximum, we can take du over dx is equal to 0. So when I will take 0, we'll get the value of x is equal to 2. So now, अब मैं ये जानना चाहता हूं कि type of equilibrium. So if I differentiate again dx2, then if I differentiate this term again, we'll get 2. The differentiation of x is 1 and minus 2 is 0. So we'll get 2. So it is clear the second derivative of this is greater than 0. So we can say my option number 2 is correct. Let's move on question number 20. If I go for question number 20, a bullet moving with speed 100 meter per second. Suppose this is the bullet moving with 100 meter per second in this direction, can just penetrate 2 planks of equal thickness. So there are 2 planks of equal thickness. Suppose thickness is t. This is. Now if speed is doubled, then the number of such planks required to stop the bullet will be. So now if I use the work energy theorem, so work energy theorem says work done is equal to change in kinetic energy. So we can use this theorem in 2 steps. In my first step, if I consider, because when bullet penetrate this plank, जब bullet left से right में move करेगी, तो plank will retard this motion. Suppose the force created by the plank is F. So what will be the conclusion by this? So we can observe the direction of displacement from left to right, but the direction of force is right to left. So angle between these two is 180 degree. So if I go for the work in this case, so we'll write force into total displacement, that is 2t, because thickness of the plank is t. So when it will penetrate the 2 plank, the total displacement will be 2t, but angle between the force and displacement is 180. So we'll use negative sign here, and that is equal change in kinetic energy. Final kinetic energy will be 0. So minus half mv square. So I have a relation minus f to ft, that is equal half mv square with the negative sign, and this is my equation number 1. If I go for the second step, because speed is double, number of such planks required to stop the bullet will be. So if I use the same equation, so we'll write force F, and if I consider the number of planks is n, so total displacement will be n times of t, negative sign will be there, and that is equal to half m 2 times of v square. Why we are going to use 2v? Because question says speed is double, and minus sign will be here. So minus minus will cancel out for both equations. Now if I divide equation 2 by 1, so we'll get nft divided by 2ft, that is equal to half mv square, and half mv square will cancel out, and I have only 4. ft is cancelled, so n is equal to 4 into 2 is equal to 8. Total number of plank required is 8. So my option number 1 is correct. Let's move on. Question number 21.